Hello friends, in this video we are going to discuss about droplet detector. Okay, that means suppose rain is falling, one drop is coming, then how to detect the drop? Is there any sensor? Yes, we can make one kind of sensor which can detect the droplet. How? We will discuss. But before going to that, I will just give you a quick recap on the principle of the capacitive sensor. The capacitance of two parallel plate capacitor is C is equal to epsilon A by D, where epsilon equal to epsilon naught epsilon R, and here epsilon naught is the permittivity of the free space which is constant, and epsilon R is dependent on the medium, that is relative permittivity of the space, and A is the common area in between two parallel plates, and D is the distance in between two parallel plates. Okay, so basically C is equal to epsilon A by D. So if we somehow able to change the environment that will affect in the epsilon R, by changing the environment obviously epsilon R will change, so the capacitance value will change. Otherwise we can change the area, common area in between two parallel plates, then the capacitance value will change. Otherwise we can change the distance in between two parallel plates. In this way also capacitance value we can change. Okay, so based on these three principle, capacitive sensor, any capacitive sensor works. Okay, this is the basic of working principle of capacitive sensor, any kind of capacitive sensor. Now let us discuss droplet detector. See here, these are the two plates of the parallel plate capacitor, this plate 1 and this plate is number 2. Okay, and we are providing AC power supply here, and these are two electrodes or parallel plates conducting metallic parallel plates. Now suppose one droplet is coming from the upside and it is passing through the two parallel plates. Okay, initially when the droplet was not there, suppose air was there, then the capacitance value was a fixed value, but when the droplet entered in between two electrodes, then the relative permittivity of the space in between two electrodes changed, and the capacitance value changes if the relative permittivity of the space in between two parallel plates changes, because we know C is equal to epsilon naught epsilon R A by D. So obviously if epsilon R changes, the capacitance value will change. So as soon as the droplet enters in between two parallel plates, obviously the relative permittivity in between the two plates changes, and as a result the capacitance value will change, which can be used for signal processing, and the output, corresponding output will show us that yes, there is a presence of droplet, due to which the capacitance value changed in this case. Okay, so this is just simple application of this kind of sensor. This was invented in a in an university of Germany, and this is very important because there are many advantages of this sensor. Because see, this is non-contact based measurement. Okay, so obviously it will free from any kind of contamination. Okay, so there are lots of advantage, and here one more advantage of this sensor is this sensor also can measure the volume of the droplet. If the droplet's dielectric constant, that is epsilon R, is fixed or known, and the velocity in which it is coming downward is known, then the sensor can directly relate the droplet's volume with the change in the capacitance. Okay, so this is very important sensor in our real life. Okay, this is all for this video. In my next video I will show you some more concepts. Thank you for watching.